students, welcome to our physics class. So let's discuss from the top. This chapter includes Thomson atomic model, alpha particle scattering, Rutherford model of an atom, distance of closest approach, Bohr's atomic model, Bohr's theory of hydrogen atom, atomic spectra, spectral series of hydrogen atom, and limitation of Bohr's theory and some important terms. In this previous lecture, we already discussed from this part that Thomson atomic model to distance of closest approach. Then in today's class, let's start the next part, Bohr's atomic model. In previous class, we discussed about Rutherford atomic model. In this concept, he proposed that all the positively charged particle is gathered at center, that is called as nucleus, and electrons revolving around the nucleus in any arbitrary path, any spiral path, so that they emit energy continuously and gradually collapse into the nucleus. So he unable to explain or fails to explain about the stability of an atom. To overcome the drawback or remove the drawback, Niels Bohr in 1913 suggested some concept that electrons are revolving around the nucleus, but they do not emit energy continuously under all condition. Under all condition, they do not emit energy. If they emit energy, they exist some certain condition, and that concept is explained by him in his model. Now we go to the four basic postulates of Bohr's model. And the first postulate is that all the positively charged particle is gathered at center. That center is called as nucleus, as same as the model of Rutherford, and electrons are revolving around the nucleus. Electrons are revolving around the nucleus in a fixed circular orbit. Fixed circular orbit. That circular orbit is called as stationary orbit or stable orbit. The fixed circular orbit is called as stationary orbit or stable orbit. And the second postulate is, as electron revolving around the nucleus, the centripetal force required by an electron for revolving around the nucleus is provided by the electrostatic force of attraction between nucleus and electron. So this concept, we go to that formula, that we know that centripetal force, that is mv square by r. We take that electron in a particular orbit have radius Rn. If that electron is nth orbit, then that radius is Rn, and whatever be the velocity of an electron, that is taken as Vn. So Vn square by Rn is equals to electrostatic force of attraction between nucleus and electron. So what is electrostatic force of attraction? That is 1 by 4 pi epsilon 0 Q1 Q2 by r square. So Q1, what is Q1 and what is Q2? Take as this one is Q1 and this one is Q2. So what is Q1? The charge of proton. So if we take an element X, Z is the atomic number and A is the mass number. Z is the atomic number and A is the mass number, where atomic number is equals to number of proton, whereas mass number is equals to number of proton and number of neutron, the sum of number of proton and neutron. So if in this element Z is the number of proton, then what is the charge? That total charge is Ze, and electron charge, take as electron charge E. So 1 by 4 pi epsilon 0 Ze into E by r square. इन दोनों के बीच डिस्टेंस कितना है? Rn. So Rn square. So here Rn cancel. So here that formula is mvn square equals to 1 by 4 pi epsilon 0 Ze square by Rn. The third postulate is electron can revolve around the nucleus in those circular orbit in which the angular momentum of the electron is integral multiple of h by 2 pi. Integral multiple of h by 2 pi. Take as that angular momentum L. And L is the In your first year syllabus, angular momentum is already discussed. So we go to direct formula that L is the vector product of position vector and momentum. Vector product of position vector and momentum. So what is position vector? Here the position vector, that is Rn, and here momentum, that is P. Momentum is equals to mv, mass into velocity. So put that value Rn into mv. So as we take vector product A cross B, that A cross B equals to AB sin theta. So here Rn mvn sin theta. So here take that velocity along this direction Rn, that is the vector position vector, and in दोनों के बीच angle है 90 degree. So here put that value theta equals to 90 degree. So as theta equals to 90 degree, sin 90, that is 1. So answer कितना है? M Vn Rn. L equals to M Vn Rn. That is equals to integral multiple of h by 2 pi. That means L, that is the angular momentum, that is mvr, mvn Rn is equals to nh by 2 pi, where Vn, that is the velocity of an electron in nth orbit, Rn, that is the radius of an electron from nucleus, where electron is possessed in nth orbit. This condition is called as quantum condition or quantized condition. So what happened in this condition? Bohr himself puzzling to give an answer about quantized angular momentum of an electron. Quantized angular momentum of an electron, Bohr himself puzzling. After 10 years later, de Broglie proposed some concept that we discuss later. Now go to fourth postulates of Bohr's atomic model. In fourth postulates, an electron revolving around the nucleus in a fixed circular orbit. That circular orbit is called as stationary orbit. At that circular orbit, it do not radiate energy. When electron jumps from higher stationary orbit to lower stationary orbit, take as that inner circle, that orbit take as n equals to 1, and that outer circular orbit take n equals to 2. Then that inner circular orbit, that energy possesses E1, and the outer circular orbit, that energy possesses E2. When electron jumps from higher energy level to lower energy level, or higher stationary orbit to lower stationary orbit, it emits energy in the form of electromagnetic wave. In the form of electromagnetic wave. At that condition, what is the amount of energy it emits? That E2 minus E1 is equals to E. That E is the amount of energy emitted by the electron when it jumps from high stationary orbit to low stationary orbit, and that E equals to h nu, where nu is the frequency of this electromagnetic wave. Nu is the frequency of that electromagnetic wave, whereas we know that nu equals to c by lambda, or we put the value of nu in this equation, that h into c by lambda, where lambda is the wavelength of this electromagnetic wave. So we got the formula E2 minus E1 equals to h nu, or h into c by lambda. Next, as electron jumps from inner stationary orbit to outer stationary orbit, or lower energy state to higher energy state, at that condition electron absorb energy, or any energy is supplied to that electron, so that that electron able to jump from lower stationary orbit to higher stationary orbit, or lower energy level to higher energy level. So take here that energy E1, and here that energy take as E2. Then say here that formula E2 minus E1 is equal to h nu, where h nu is the energy supplied to the electron. H nu is the amount of energy supplied to the electron.